All right, just going through the solutions here to the practice questions. So in case you wanted to kind of go through it and you weren't sure. So once again, we do from angle A for the first three, right? So we're doing the opposite side, the adjacent, and then across from the right angles, the hypotenuse. So the sine of A, remember, for so, ka, toa. And then we're doing opposite. So opposite here, right? Opposite over hypotenuse. So that's 4. Hypotenuse is 5. The cosine is adjacent over hypotenuse, right? Ka. So adjacent is 3. Hypotenuse is 5. And then tangent is toa. So it's the opposite, O, over A, the adjacent. So the opposite from A, once again, is 4. And the adjacent is 3. And there's our ratio. All right. Now, if we go with angle B instead, then it switches. So remember, this becomes the opposite side. This now becomes the adjacent side. And then this still stays our hypotenuse. That doesn't change. So from the sine of B, opposite, okay, once again, it's still O over H. So opposite is 3 now, and the H is still 5. The cosine of B is A over H, all right? And so the A from B now is actually 4, and the hypotenuse is 5. And last but not least, the tangent of B, right, is opposite over adjacent. Okay. And so the opposite of B is 3, and this time the adjacent is 4. So once again, sine of A, right, is equal to the cosine of B. Cosine of A is equal to sine of B, and these are the reciprocals, okay? And think about the challenge question. Well, why is that working, okay? And look at this. This will kind of help you out with that, all right? Number 2, same thing. So starting with sine of D. So my reference angle now is angle D, okay? So across from going from D, so the hypotenuse, once again, is always across from the right angle. D, that's our opposite side, is radical 3, and that makes 1 the adjacent. So the sine of D is O over H, and you forget, remember again, so ka, toa, okay? And then I do the opposite of D, so that's radical 3 over the hypotenuse, which is 2. All right, the cosine of D is the adjacent, so that's A over H. The adjacent is 1 over 2. And then the tangent is O over A. So that's O over A, right, toa. So the opposite is radical 3. And this time the adjacent is 1, okay? Which is also just equal to radical 3. All right, so let's do the sine of E. So going from E this time, starting over here, all right? Now we switch. Now this is the opposite side. This is the adjacent side, and this is still the hypotenuse. So the sine of E is O over H. So the O now is 1, and the H is 2, right? The cosine of E is adjacent over hypotenuse. So the adjacent is radical 3, and the hypotenuse is 2, so radical 3 over 2. And last but not least, the tangent of E is opposite over adjacent, so O over A, which is 1 over radical 3. Now, we're going to go over something real quick. This is technically not in simplest radical form because there's a radical in the denominator. And so how do we get the denominator, the radical from down here, right, out of here? And the answer is how to get rid of a radical. You square it. So what we have to do to square something, we really multiply it by itself. And this is called rationalizing, okay? So we're taking this denominator and we're making a rational number out of it because right now it's irrational, okay? So we multiply by itself. And really what we're doing is we're really multiplying by 1 because that's what radical 3 over 3 is. So that's why this is equivalent because we're really just multiplying by 1. So radical 3 times radical 3, remember? Any radical times itself is on the right side, which is just 3. And then we get 1 times radical 3, which is radical 3. So this is technically radical 3 over 3. If you got that one, awesome. You crushed it. If you got this, that's great. You're recognizing your ratios. And then this is just the rationalizing part, which is just a little extra. So that's it for today. Enjoy yourselves, guys. I'll post these answers as is and also the video. So once again, enjoy your weekend. See you guys later.